Wilkes.
I'm Connor LeBlanc.
I'm Giuliano Romano.
And I'm Christian Pettibon.
And we're the Billboard Hot 100. The way we listen to music has changed. The days of people walking into a music store and buying their favorite artist CDs are over. We now have much easier access to our favorite artist music thanks to apps such as Spotify and Pandora. The emergence of social media has also given fans the ability to keep up with their favorite musicians' everyday lives. This has opened the door for musicians to form a much more personal relationship with their fans, allowing fans to keep up with their favorite artists make them even more loyal. Before, artists were just figures that made music and fans didn't really get the chance to know much about them. They now have the opportunity to share about themselves and talk about everyday things and be much more personal to their fans. If artists were able to understand the effect that their social media presence has on sales, it could be a great benefit to their career. This leads us to the question of, can you predict record sales based on social media involvement? That's why we created a regression model to predict the record sales.
In order to run this regression model, we first had to identify 8 independent variables that could have a direct correlation to the artist's record sales. By looking at different artists' social media presence across several different platforms and collecting data, we were able to create a data set composing 42 independent artists for this regression model. Before running the regression model, we first had to clean the data in order to eliminate any outliers in the data set. Through this, we ended up with a total of 35 artists, then were able to begin our analysis. We decided to do several scatter plots in order to determine whether or not there was either a positive, negative, or no significant correlation between the independent variables and the predicted record sales. As you can see in Figure 1, there appears to be somewhat of a positive linear relationship between Twitter followers and record sales. In Figure 2, there also appears to be a small positive linear relationship between Instagram followers and record sales. However, this relationship is so small that it could be deemed to be insignificant. And in Figure 3, you can see that there is a slight negative relationship between years active and record sales. As you can see on the current slide, we decided to use a correlation matrix to determine the exact correlation between the dependent and independent variables, and the exact correlation between independent variables themselves. The weak correlations are highlighted in purple. A correlation between negative 0.3 to 0.3 is considered weak. The strong correlations are highlighted in blue. The correlations of 0.7 and above are considered to be strong. We did notice some strong correlations, for instance, between X1 and X3, as well as X3 and X6. In these results, we also noticed a moderately positive relationship between most variables.
For our first regression model, we decided to run a multiple linear regression using all 8 variables. As you can see in the least squares estimate table, X5 proved to be an insignificant variable. All other 7 variables are significant because they have a low p-value, which means that the predictor's value added was beneficial to the model. Thus, the team decided to run a second regression model using every variable except for X5.
By doing a stepwise backward selection, we were conducted to remove X5 from our model and produce our second regression model. From our regression statistic table, we focused on the adjusted R-square, because R-square can only go up by adding variables, but not the adjusted R-square. Our adjusted R-square is 89.92. It is slightly less than the 89.96 from the first regression model, but it's still high for a regression model with 7 variables. So it means that our model can explain 89.92% of the variability of the record sales. During a regression analysis, it is also important to look at the p-value of each of the predictors. As you can see on the least square estimate table from this slide, each p-value are under 0.05, which means that by omitting X5, now all predictors are beneficial to the model. Consequently, we consider that That was our best subset of independent variables. The final equation of this model is displayed in the blue box of the current slide.
Value to our regression model, we decided to calculate the mean absolute percentage error, or MAPE, in order to have a measure of the prediction accuracy if artists use our model to forecast their record sales in the future. We got a MAPE of roughly 8.43, which is acceptable since the group decided to make assumptions when selecting the independent variables in the model.
Through our analysis, not only were we able to identify 7 predictors that give a direct correlation to future record sales, but we were also able to identify and eliminate a non-significant predictor, which not only improves our model by not overfitting it to our dataset, but also prevents artists from spending time and money investigating predictors that have no direct correlation to record sales. This means that our model can be applied to a wide range of datasets and not just the 35 samples that we collected.
Which means with a MAPE of 8.43, the predicted value that the artist will get when using our model is going to be pretty close to the actual record sales that they will receive.
However, our model is not perfect. We noticed that our model is limited due to the standard error of estimate being around 11 million. Knowing that we worked with values between 75 and 230 million, our standard error of estimate is slightly high. So a bigger sample size would help increase the accuracy of our model.